Hey guys, welcome back to another episode of the Real Hacker Hours podcast. Today, continuing with working with Semgrep, what I want to do is I spent some time making a tool. It's not done yet, but a lot's been done for it, even though this tool is basically just the Semgrep wrapper. I want to see if this tool will work. So what I'm doing now is I'm just trying to run it against targets that have known CVEs and see do they find the CVEs, and if they find it, that will lend more credibility to this being an effective tool. Right now, what I'm doing is I just went on exploitdb.com. Let me pull up the link. Come on, Firefox. I'm going to pause it while the link loads. Okay, I just went on exploitdb and just found like a mini FTP server that has a bug in it from this GitHub. Let me just pull it up. Yeah, not a very popular FTP server, but I just chose this just to test that out as the first one. Cool. So here it is. Compiled it with make, and I ran my tool against it first, and these are just the things that I found. Looking through it, a few interesting things. We see a few sprint Fs with %s. See it for perms, data buff. Looking through here, this one right here seems the most, or like these two right here, at least at first glance, seem the most interesting. Reason for that being, it's %s with dir. Now, one thing about this, with this %s, if we control the data going into the %s, we have a bug that we can at the very least, use the DOS and potentially get RCE with it. And the thing is here, FTP, a lot of the functionality is like creating and uploading files, and the fact that dir is going into a format string that's created in it would lead me to believe that yeah, that we might have some control over the directory name, and that may be leveraged here for a potential overflow. Now, another thing that we have to worry about is there might be a size check directly before the sprintf or somewhere before that would make it not able to actually overflow, but oh well, we will see. Cool. So, first off, I'm just gonna, all of these were in the FTP proto.c. I'm just gonna quickly pop it up and see exactly where that line is. Ideally, what I'm gonna want to do is I'm gonna want to see like that. Well, first take a look at the source code file to just see, hey, does it look like we'll be able to hit it or not? And then I would want to actually, through dynamic analysis, actually hit that line of code and see, okay, does this look like we'll actually be able to exploit it? It is line 774, so let's just scroll down to it. 774. So these right here do make directory. MKD is an actual FTP command. So what I'm gonna do is I'm gonna try, and actually looking at this, it looks like text. Where's text? Text is a char pointer. Okay, dir equals this string length dir. Where does dir come from? Get current working directory. I'm gonna check out size. Okay, cool. So looking at it, text is a char buffer of size 1024. Dir is a buffer of size 1024 that has 1024 bytes scanned into it. Text has it written potentially 1024 bytes from dir, and then whatever whatever this sesarg value is. Oh, it might be this might be the argument to the command, which would be the directory created, which would make sense because looking at it here, I always said like, yeah, it says here created, and it would make sense, yeah, because we're creating a directory. Let's say we're correcting the directory hi, I would say like hi created. So cool. Let's stop speculating and actually try to run this. So let's try running this in GDB. I hope must be started as root. Oh well. Let's do this. Cannot assign requested address. I wonder if I already have something listening on that port. Let's check. Hmm. Does looks like I already have something listening on it. Port 21, I believe. I'm just gonna Google FTP port 21, I believe. Yep, port 21 is at least used for the command. So let me check. Okay, so VS FTP is running, so I'm just gonna kill it. Let's see. Okay, so that isn't running, so I should be able to run this. I'm actually going to have to give it a actually. It's probably still listening. Not anymore. Let's try it now. Cannot assign requested address. I'm gonna. What address is it actually trying to bind to? Let's see. Nope. I'm gonna do a grep. I have the source code. Let's make this easy on us. Hacker ID, Semgrep targets, grep tech IR. What is the htons, I believe, is a function. Port sysutil.c. Let's take a look in there. Sysutil.c. htons. Port is equal to. Okay, so TCP server is called with the host and the port. Let's see where this is called from. This is called from IP. Main.c, who would have guessed? Port 5188. Okay, not expecting that. And turntable address. It says it prints it out. What is it? Turntable listen address. What is my current IP? .1.187. Okay, the IPs are not matching. I need to change that. Just gonna grep for this string to see where it is. Where is it actually established? Looks like there's a conf. Many ftpd.conf. Okay, it's probably this. Let's change the listen address to this IPv4 address. Cool. Let's try running it now. Okay, it's able to be ran. Cool. Now, what is the address? It's this. Not .10, it's .187. Telnet. Oh, what port is it? 5188. Okay, does this tell us what the username and password are? Nope. Time to guess. Print working directory. Okay, so it doesn't look like it has auth. So, oh yeah, so what I'm doing here, I should probably explain. FTP is a clear text protocol, meaning that the actual data transferred to communicate is all just clear text commands. I happen to do past work on side projects and stuff like that. I kind of have like a good chunk of like the network protocol stuff memorized, so I'm just connecting it to it directly with Tone and just running the FTP commands directly. PWD prints the current working directory, which is this. I'm going to try make directory. Let's try making print 0 times 1000. This isn't Python 2, it's Python 3. You think I would know that after 3 years of using Python 3 or something like that? Let's try making that directory. Create directory operation failed. F cd f change working directory f. Okay, so now we're in the F directory. I'm gonna try making the current working directory around 1,000 characters. The reason for that being is looking at. Let's go back to the sprint if we were interested in looking at. Where was it? Sprintf. Okay, here it is. So looking at here, the buffer we need to overflow. Granted, I'm not yeah, it's 1,024 bytes. If we can get the bytes that we can write is the directory and the session argument. Directory is set equal to the current working directory. If we can get this as close to 1024 with a large argument, we might be able to overflow it, or we might not be able to. Let's see. I'm gonna try, instead of making an argument that's 1,000 bytes, let's just try. Where's my path? No, I'm just gonna make a Python terminal here. Print. I'm gonna try 500, and just if that doesn't work, I'll just try decreasing amounts until I get something that works. So let's do make directory. Directory create operation failed. Too much. Let's try 250. Make directory. Okay, so 250 works. Make directory. Change working directory. So and we see stack smashing detected. So that would lead me to believe that this here is indeed the stack buffer overflow that we initially flagged it for. However, what I'm probably going to do is, what was this? Okay, I believe it's this sprintf call right here that actually got flagged. However, I'm going to set a breakpoint for it to actually confirm. So let's see. Do we have symbols? Yes, we do have symbols. Let's see. First sprintf, second sprintf, third sprintf. I'm just going to set a breakpoint for both of these. Well, no, I'm going to pause this for a second to think about how I want to do this. Okay, cool. So how I'm pretty much going to do this is I'm going to set a... Well, first off, I'm going to try just running this and seeing how many times I can just make a new directory and traverse into it before the buffer overflow triggers. Oops, misclicked. Let's do... Wait a second. Wait, yeah. CDF. Put working directory. Change working directory. I'm not doing this right. Hang on a second. Telnet 192.168. No, why do I keep going to that address? What's this one? .187. Port 21. Not port 21, it is port 5188. So let's make the directory so we traversed one level, 2 levels, 3 levels. This might be it. 4 levels. Okay, so the 4th level in, we cause a stack overflow. Cool. So in that case, we should be able to go 1st level, 2nd level, 3rd level. Next make directory that we do should cause a buffer overflow. Actually, before we do that, I'm going to set a breakpoint for do make directory. Let's disassemble it. And I'm going to set a breakpoint for these 2 addresses. These 2 addresses should be these 2 calls right here. And continue that. Copy the string which will act as. Oh. It closed our connection on us. Change working directory. 1st level. 2nd level. 3rd level. And let's do this. This should. Okay, this is a bit interesting. It didn't. Maybe debugging the. No. Detaching after. Might have just been debugging the wrong process. Since there's a fork, I'm going to try restarting this. Break. I'm just going to break at do make directory. Since we know there's 4 levels deep, we will cause the buffer overflow. We only need to do the make directory once, which should be the one to actually cause the overflow. We can just traverse into the directories we created so far. So let's do that. Change working directory, 1st level, 2nd level, 3rd level. And we get this. Nope, that did not work. Okay, cool. So it's looking like it's happening. We're gonna have to. What is it? This command? Show follow fork mode. Hang on a second. I'm gonna Google. I'm probably gonna have to set a command. Okay, I googled it. Basically, when when the process forks off as the option to whether continue debugging the parent process or the child process. Pretty sure the child process is the one that is actually handling the process, or actually handling the FTP commands. That is supported by the fact that we see that we're able to get a stack smashing and it terminated the process, but the FTP server is still clearly running. Also supported by the fact that we can see here that the follow fork mode was in parent, so I just switched over to child. And for breakpoints, I'm just going to reset the breakpoint for do make directory. because I know sometimes switching the contexts messes with breakpoints. Actually, I'm going to do that after I connect it. Okay. Detached from fork and attached to the child process. That's what we like to see. Let's go 3 layers deep. Change the 2, 3. Cool. I'm going to set the breakpoint now for do make directory. And this next command should trigger the breakpoint. And we are here. Step. I'm just going to step through it. Let's see which sprintf we hit. To make directory call. Oh, this is actually making the directory right here. Okay, so the directory operation failed, probably because it already existed, so I'm going to make that. Let's try this. Okay, so we're back here. Let's step through here. Hopefully this one doesn't fail. And I forgot to copy it correctly. I'm just making so many smooth brain mistakes. Let's make sure that this one's okay. This is copied. Okay, this one should work. Okay, this one did work. Okay, so right now in the source code with this function call, we are here. I'm just gonna break on this instruction so we can just get past this one. Okay. So now in this function we are approaching this get current working directory function. Actually, let's set a breakpoint for here. Okay, so here, get current working directory, string length. Okay, so we're at this sprintf call. I see it's %s/%s created. So this is this sprintf call right here. I believe this is where the buffer overflow actually happens in this function call. We can confirm that looking at info frame, RIP at this. Let's take a look at here. So you can see it's this nice memory address right here. Let's see what it is after it. That is interesting. Does not appear to have changed. I wonder if what is going on here is FTP reply. Is the buffer overflow happening in FTP reply? Hang on a second. This is getting a bit interesting. Where is this function defined? Mini grep tech IR FTP proto void FTP proto.c. So this could be void. Okay, so here's the function call. Okay, it's blatant what's going on here. It's just taking text and writing it to an input buffer, which is then printed. Probably that's the actual buffer flow that we're having. So let's go ahead and try it. I'm going to set a breakpoint for here instead, and then let's try to hit it. Actually, first let's FTP reply. Actually, no. Let's get saturated first. Set. What is the follow fork mode child? And let's continue on. Okay. We'll just go into, nope, not there. I am just failing at copying and pasting. First layer, second layer, third layer. Okay, this next one should be the buffer overflow. But before we do that, what is the function? Do make directory. Gonna set a breakpoint for right here since this function is probably the one that's actually overflowing it, despite contrary belief. Print Python 3, print 4 times 250. Make directory. And for breakpoints. Okay, so here we are. Gonna set a breakpoint for right after this repeat instruction. Not defined. What? Hang on a second. Oh, okay, I forgot the asterisk. Okay, so we're here. Setting up the sprintf info frame. Let's take a look at the stack or the stage return address. It's that. And we see it is now something else. Let's take a look. Created. Okay, cool. So we can see that we are able to overflow it with data. And let's continue onward. String length. And fails the stack cookie check, so it gets that. Cool. So effectively, using this tool, while it did, well, we see here that what this tool was able to do was able to have us effectively point us in the right direction for finding a Stack Overflow bug. Now how usable this bug is will require further investigation, but it found the Stack Overflow bug, so I'm going to mark it as, oh hey, this tool did actually find something. And actually, also, wait one second. Let's close out of here. Let's go back to the original findings. Cat output. So, where is it for? FTP reply. Line 221. Okay, so it flagged this sprintf call right here, which this sprintf call is actually where the real buffer overflow happened, so it did actually flag the bug that we found. This is good. It worked in the first tool, granted, just because it works once doesn't mean it's good or anything like that. It has to work a ton. And let's see, what is the actual like bug that was reported here? Exploit mini parse conf load setting. Var var settings is a char pointer which will be split into key and value. So it looks like the bug that they're talking about here is dealing with the configuration files, and just a local buffer overflow. This clearly is not a local buffer overflow because it deals with, oh hey, we're actually extending commands and doing it remotely, we're not even touching the conf files. So it looks like this tool found a different bug than the bug that's actually reported here, which is kind of cool, but yeah, I'm gonna see if it's available against if the bug is currently present in the newest version, and if it is, I will submit a PR. Actually, let's just check right here. This is the newest version of it. Files ftp proto.c. What is it? FTP reply. Looks like it. I'm just gonna quickly pull this repo down and see if it works. cd Semgrep targets, make directory, test, git clone. Wait, no, I need to edit the comp file first if I recall correctly. And where's the port? Let's change this to 5189. Cannot. What is my IP address? .187, okay. Not 178. Okay, let's just go ahead and see if this will work. Gonna copy that. No FTP. I'm just telnetting into the 187.5189. What is the port? 5189. Okay, it appears that even though I set the conf file, it doesn't actually respect it doesn't respect the port I specify. And this one should crash it if it still has the bug. Oh wait, no, I forgot to actually traverse the directories. Okay, and we can clearly see here that our commands are being ran, so we are actually connected to it. And this one should be the one actually. Okay, stack smashing detected, so it was never actually patched. Cool. I'm gonna submit an issue to the repo even though it has 17 stars. Why not? But yeah, it's been 35 minutes, so thank you guys for watching. In conclusion, we basically used the Semgrep tool to just like find a bug in a binary, or not a binary, a code base that we knew had bugs, but we found a different bug than what was reported. Thank you guys for watching. See you later.